So continuing off from last video, let's start. So I put the 3 in there. I believe I actually need to put this in a P array. This function here. Let's see. Yep. And now I need to find a function that can give me all the pipes. So if you want to do a function of like 6, 7, 8 pipes, you can find all the pipes. So let's say n value of pipes is equal to, what should it be? You're going to have to use the shape function. So I think it's pipes dot shape 0. Shift enter. So let's say n pipes. Yeah, it gives me 6. And now I'm going to need the relative roughness of each pipe and the diameter of each pipe given. So let's do that. What should I name it? So pipes ED and pipes D. So it should be equal to n pipes to n pipes. That's in the middle. Say MP full in pipes ED and MP full. Let's do it here. In pipes D. Let's check it. So let's say pipes ED. And yeah, and I think we need to make from and to integers. So from nodes, yeah, we're gonna have to make these integer values. So what we're gonna have to do is we're gonna have to put as type. So dot as type as and np dot int 32-bit is what we're going to want. We're going to do that for the 2 nodes eventually as well, so we might as well do it now. And 32. And yeah, that gives us integer values. So next thing we're going to do, we're going to get the calculated heads. So define C flow. Well, it's head. It's calculated flow actually, but you're gonna need heads. You're gonna say flow is equal to, come on, np. So you want to 0, np zeros of n pipes. So it's gonna say, I'm pretty sure the n is 4. It's a 4. In range, or I in range in pipes. You're gonna have, what should I set this equal to? Should be delta head. So I have delta. So let's say delta head, just a long version, is equal to, it's gonna be 2 nodes. 2 nodes I minus from nodes. F for nodes. I don't know if this is the right syntax for it. It might be. Let's just keep it. So yeah, it's going to be the 2 nodes. So what's flowing in from the 2 minus the flow from the from. It makes sense since flow's going in and flow's going out at the same time, and they're gonna have to equal. So I believe I need, when I'll get back to code, we're gonna have heads actually there in front of it. That's why we have the heads function. Shift enter. You're actually going to return some value eventually. put space between there. And let's see. So we got heads equals MP array. So we have 50, 40, 30, 20, 10. Oh, that's bad. And we're going to see flow. I might have to print, so I'll say print 2 nodes I from nodes I. And it's still not giving me a CFlow heads. That's my bad. And that's not exactly what we want here, so let me put another line. So another 9, we're going to have to change here. We're going to put in the flow function that we already defined, and then put in the values from there. So let's say print, so flow delta H. And I go, what do I have there? L values I, K values I. I don't need to or from nodes. I'm gonna need, let's see, pipes D I and pipes ED. Hopefully this works. Now it's syntax. So and it says K values is it's my bad. Something not call for. I think I know what the problem is. I think I gotta do this in order. So K values I, L values I. So pipes ED I. It's not delta H, it's gonna be delta head, then pipes D I. I'll make sure I have that in parentheses. It says delta. It's not called. It's literally has to be the delta H. So I think delta H is the same as the flow function up there. No, it is not. That is the issue. So you should be delta H here. So let's refine it again. And you should be delta H. It's doing. That's all. That's right. Jesus. It's saying it's on the print flows, but I don't know what's wrong with it. Because delta H doesn't need an I because it's not iterating. I think maybe that shouldn't be flows. And that is one of the things. So these numbers aren't right. So because there's an infinite. So divide by 0 encountered. We'll fix that. But first we need to find the difference between the internal and external nodes. So we got to create another function up here. So in nodes. So what we're going to, so it's in nodes equal to np max pipes. So let's say pipes. Do what we did before. So 1 dot as type int 32 plus 1. I might have to put this all in parentheses. I'm not exactly sure. So yeah, you can't do that. I might have to do that. See, N32. Oh, MP. That's my phone. MP dot N32. So that's that. If I put in a 10 here, let's see. It says failed to converge. So we need to account for if it's super, super close to 0, that it won't complete an error. So let's go back up. I believe it's right here. So if delta ABS is less than 1e to the 10. Return 0. If enter. So Control C that, move that. I believe that's how you write it, so I didn't add an underscore here, so it's a different variable. Unexpected indentation. Right. So yeah, it gets to 0 there where it didn't before. Now, I'm going to need to define calc, or let's say net Q. I believe it's heads. Well, let me change something first. We should make this flows I to get this into an array equals that. So I get that, I changed it so this works now. And now we need to define net Q, so the net flows. We're going to use as flows from what we returned up here. Flows. First thing we're going to do the same. We're going to do flows equals MP zeros. So I don't know if it's not flows, it's net Q. So net Q. Come on, let me put it. MP zeros of N nodes. Or do MP add adds, MP add, separate the internal and external nodes. Add that, so we go 2 nodes flow net Q, and we do the same thing for from nodes. So MP add net Q. Okay, C from nodes. And this time it's negative flow since it's flowing out and not in. Shift that, enter. And then we're going to return net Q. So this is it for this video, and my next video will be my final video, putting all this together to get the net flows of pipes and the net flow rates of all the pipes.